Welcome to another video about smart technology. The aim of this video is to show you how to configure a control strategy in Foundation Fieldbus Tech and also the configuration of its functional blocks. Let's create our control strategy for Foundation Fieldbus. Let's initially insert the blocks. The blocks are inserted into each transmitter. Each one will have blocks. Get the TT and create a new block. Let's take the input option in logic. Add a tag. We are going to place TTRAI and confirm it with an OK. Coming up, we will obtain our possession. Control valve for flow regulation. Create a block of PID, a control system to manage our processes efficiently and effectively. Let's put FIRAI in place. The PID option. In sequence, a new block. Make a block of analog output to send to the valve. We are developing the FIRAI project. So we have the AI, the PID, and the AO created. Let's save. We must not forget to save. Let's create our control plan with around 56 characters, joining these three blocks. Make it an application. New step. We will create a new section, a new cell for processes. Let's call it PID control. Say OK. He will create a new window. Then we will proceed to expand. Windows layout to divide the windows. Inside our PID control, we will set up a control module or loop. Let's type a name there, temperature control as an example. Press OK. In temperature control, we will click strategy with the right mouse button, opening the possibility to create the graphical part of the strategy. We'll minimize a few windows that are not currently needed to condense the workspace. Let's divide the windows into two parts, and we will pull by holding the left mouse button. Let's add to our temperature control the analog input module, the PID block, and the analog output block. To create the graphics, we will pull with the left mouse button. In the graphics area, our blocks. Save it. Next, we can arrange these blocks on the workspace for optimal organization. In Properties, we can verify the size of the blocks and standardize the block size. We set it to 100 by 80 for height and width. We are establishing a standard to facilitate the links and connections. When configuring properties, we'll assign the color black to the text, which will appear in the connections. we will arrange the blocks within our grid, arranging blocks vertically for easier access. Still, please feel free to organize yourself in any format you want. Let's save. Select the link tool. Let's connect the output of the analog input block. To create a straight line, use Ctrl and maintain a continuous trajectory. Let's enter in PID. We will take the ALT output and connect it to Casim. It only has Casim input, so you can't go wrong. Next, we must create feedback from the output back to the PID. Click on the workspace and it will automatically draw a line. We can now include the BKK win. So let's organize the labels for the ALT in BKK win and BKK Walt blocks so that it is visually much more comprehensible. Then we will save. We will formulate our strategy. Next, let us make some adjustments to the blocks. Functional. To set up the block, we can access the channel. We can also use the graphical area. Right-clicking will allow us to perform the offline setup. We can configure the target to automatic in ModBRK with the block, starting in automatic mode. Now let's set a scale for temperature. We are establishing from 0 to 500 degrees in total. We will be working with an output of 0 to 100%. Thus, ALT is the output scale. We will take and position an output of 0 to 100. We will adopt the Celsius engineering scale in our measurements and convert it into a percentage option. An L type set to indirect means we will perform the conversion. Let's save. We set the analog input. Now let's configure the PID. Offline characterization. In ModBRK, it signals if the block is in auto or manual mode. Let's establish a scale from 0 to 100%. As the block will output a value in percentage, we will set percentage, the PID's output scale as well. Let's add 0 to 100%, repeating the input. There will be no scale conversion. For gain, we will do an initial tuning. Let's set a gain of 1. And we will set a reset and a 0 for the derivative term. With this, we will have an initial configuration for the PID. You can also input the set point if you want. Let's open up the analog output block. In the target, let's configure high cascade, which is the option we will set for the analog output block. The scale should be set from 0 to 100%. If we are going to work with the OFY positioner, we can also set percentage. But if we will work using sending from 4 to 20, for example, we are sending 4 to 20 of current as well. It is possible to work with this setup. Let's finish up. We possess 3 blocks set up as an example. Let's save our configuration. Thus, we have our entire strategy complete. Let's access the Attributes option. In Attributes, we can adjust our tag if required. We can apply this to any block. Let's enter the TT. We enter the transducer. In the transducer, we can make a setting to display, visualize our temperature signal. We configure the tag we want to see. We set the index, which is the OI index. The text we will present, and we will set the monitoring option. It is Monica. Thus, we will have the ability to visualize on the display of the TT. We can do this too with our module from input in the logic of temperature. We are done. Let's access the AO in Attributes. We can alter it too. We have the display 2 of the unit for output for the logic, the FI. We are setting its name to display. Next, let's set up the display. It is already in auto mode. We will set the parameter that we want to track. In this case, we will refer to it as MV. FI 302, but we will use the name MV, which is the text that appears there on our monitor. The mnemonic now is MV. And the index is 9. We will monitor the variable. Let's shut the window. Let's save. We will have the configuration of the blocks. With this, we complete the configuration of the control strategy implementation and the setup of the blocks.